Good afternoon everyone. Today I am going to discuss about the computer network subject. So unit 3. So coming to the topic, so network layer in the internet. So in previous classes we have discussed about the internet working. So it is the continuation topic of that topic, network layer in the internet. So coming in the network layer in the internet, we are having some content, that is IP version 4 protocol and IP address, IP version 6, internet control protocols, OSPF and interior gateway routing protocol, BGP, the exterior gateway routing protocol, IGMP, internet group management protocol. So these are the different contents I am going to explain now. So coming to the first one, so IP version 4 protocol, IP version 4 protocol. So what is meant by this? So in this protocol, an appropriate place to start our study of the network layer in the internet is the format of IP datagram themselves. So an IP datagram consists of a header part and a text part. So the header has the 20 bytes. So header has the 20 bytes, a fixed part and a variable length optional part. The header format is shown in this diagram. So this is the diagram we are having. So if you see this, the internet protocol responsible for transmitting the packets from source to destination. An IP datagram packet consists of, so what is the responsible of IP? It transmits the packets from source to the destination. An IP datagram packet consists of a header part, okay, and a test part, header part and test part. So in this header has 20 byte, header has a 20 byte fixed part and variable length optional part. So okay, now so this is the diagram, this is the IPv4 internet protocol. So in the header, so coming to the version is nothing but the version field. This is the version field. So complete its size is 32-bit. So here every point having the explanation. Version means the version field. This is the version field, and this is the this is nothing but, version is nothing but it keeps the track of which version of the protocol the datagram belongs to. Version 4 dominates the internet today, and that is where we have started our discussion. IPv6, the next version of IP, internet protocol was defined more than decade ago, at only just beginning to be deployed. Since the header length, this is the header length, okay, the header length, IHL means header length, is not the constant. A field of header, ILHS, is to provide to tell how long the header is. So it is the 32-bit word, and in this we have 32-bit words. The minimum value is 5, which applies when no options are present. The maximum value of the 4-bit field is 15, which limits the header to 60 bytes and the options field to 40 bytes, the option fields to 40 bytes. Next is differentiated services. So what is meant by differentiated services field is one of the few fields that has changed its meaning slightly over the years. So originally it is called the type of services field. So it was and still is intended to distinguish between different classes of services. So various combination of reliability and speed are possible. So this is called the differentiated service. Next, coming to total length. What is meant by total length? It includes everything in the datagram, both header and the data. The maximum length is 65,535 bytes. Okay. So this is called the total length. Next, identification. So what is meant by identification field? It needs to allow the destination host to determine which packet a newly arrived fragment belongs to. All the fragments of the packet contains the same identification value. So next come to unused bit. Next comes to unused bit, and which is surprising as available real estate in the IP header is extremely scarce. So, then come to 1 bit. If we come to 1 bit field related to fragmentation, so DF, here we are having the DF. So, DF stands for don't fragment. It is an order to the routers not to fragment the packet. So, MF is nothing but stands for more fragments. All the fragments except the last one have this bit set. It is needed to know when all the fragments of the datagram have arrived. Okay. And in this fragment offset field tells where in the current packet this fragments belongs to. All the fragments except the last one in the datagram must be multiple of 8 bytes. The elementary fragment unit, since 13 bits are provided, so there is a maximum of 892 fragments per datagram. So, this is called fragment offset. Next, coming to T2L means time to leave. Okay. Time to leave field is a counter used to limit packet lifetime. It was originally supposed to count time in seconds, allowing the maximum lifetime of 255 seconds. It must be decremented on each hop and is supposed to be decremented multiple times when a packet is queued for a long time in a router. In practice, it just counts hops. It just counts the hops. When it hits 0, the packet is discarded and a warning packet is sent back to the source host. This features prevents packets from wandering around forever, something that otherwise might happen if the routing tables ever become corrupted. So, this is called the time to leave. Next, coming to protocol field, it tells which transport process to give the packets to. TCP is one possibility, but so are UDP and some others. Since the header carries vital information such as addresses, it rates its own checksum for protection, the header checksum. Okay. So, the header carry the source. Next one is a source address. Source address and destination address indicates the IP address of the source and destination network interface. The options field was designed to provide an escape to allow subsequent versions of the protocol to include information not present in the original design, to permit experiments to try out new ideas and avoid allocating header bits to information that is rarely needed. The options are allowed by 1 byte option length field and then 1 or more data bytes. The option field is padded out to a multiple of 4 bytes. Originally, the 5 options listed in the diagram. Okay. So, this is called the option field. This is the explanation of this IP version 4 protocol header. Okay. And next, coming to this is the list. Security, options and description. We are having security, it specifies how to secret the datagram is. Next, strict source routing, it gives the complete path to the followed. Loss source routing gives the list of routers not to be missed. Record route makes each router appended its IP address. Timestamp make each router append its address and timestamp. Okay. So, this is the options of the IP. So, this is called the first one. Next, the second one is the IP address. So, defining a IP4 is its 32-bit address. Every host and the router on the internet has an IP address that can be used in the source address and destination addresses fields of IP packets. It is important to note that an IP address does not actually refer to the host. It really refers for network interface. So, host is on 2 networks. It must have 2 IP addresses. So, in practice, most hosts are on one network and have one IP address. So, the IP addresses are hierarchical, unlike Ethernet addresses. Each 32-bit address is comprised to a variable length network portion in the top bits and the host portion in the bottom bits. So, the IP address are written in dotted decimal notation, where each of the 4 byte is written in decimal from 0 to 255. So, for example, the 32 hexadecimal addresses that written as 80D00297 is written as 128.208.2.151. So, the network addresses, the network numbers are managed by the non-profit corporation called Internet Corporation for assigned names and numbers to avoid the conflicts. IP addresses were divided into 5 categories listed. The allocation has come to be classful addressing. So, this is the IP address formats. So, coming to the explanation of this diagram. So, here I am having the class A, and the class A, B and C formats allows for up to 128 network. Okay. So, class A, B, C up to here it allows the 128 networks with 16 million hosts each, that is 16,384 networks with up to 65,536 hosts each, and 2 millions networks, example LAN, and with up to 256 hosts each. Okay. So, also supported it is multicast, the class D format, in which the datagram, this is the multiclass address which datagram is directed to multi-host address beginning with 111 1111 or reserved for use in the future. Okay. So, this is the working of this IP address format. Okay. Next, coming to IPv6 version, IP version 6. So, in this we having some disadvantages of IPv4. So, addressing space, okay, less addressing space, supporting support for real time applications, and IPv4 does not provide facility for managing and reserving bandwidth, less security. So, these are the disadvantages. Okay. Less address space, 32-bit address. Okay. So, these are the disadvantages. Okay. So, and address space, what is mean by address space? So, the IPv4 address is a 32-bit, which allows to allocate a 2 power 32 address. IPv4 present 2-level addressing hierarchy, that is network numbers, host numbers. Each network if is identified if it is identified with one or more unique addresses, the 2-level is convenient, but waste of the address space. Okay. So, next next is support for real time applications. So, what is mean by support of real time applications? So, in this so services such as the transmission of real time audio, video are becoming common nowadays. So, IPv4 does not provide managing and reserving bandwidth, no security at the network layer. So, growth of TCP and IP usage into new areas will results in a rapid growth in demand for unique IP addresses options. It is used for network testing and debugging. So, next IPv6 Internet Protocol version 6, Internet Protocol version 6. So, IPv6 includes the following enhancement over IPv4: large address space, okay, large address space, improved option mechanism, increased address flexibility, support for resource allocation, security capabilities, that is the encryption and decryption, encryption and encryption and the encryption in the IPv6 provided confidentiality and integrity of packets. It supports real-time video. IPv6 uses the less bit address, which allows the allocate 2 power 96 addresses. Okay, so this is called the Internet Protocol version v6. Okay, Internet Protocol version v6. So in this I having the diagram. This is the diagram, and so this is the diagram. I having the here also 32 bit. This is also have some explanation. So this is the fixed header of IPv6. So what is mean by version? So version, it is the 4 bit in size. The version is a 4 bit inside. It specifies the Internet Protocol version number, defines the priority of packets. Okay. Next coming to priority. What is mean by priority? So it is the 4 bit field defines it define IP Internet Protocol version number, and priority is nothing but it is a 4 bit field. It defines the priority of packet with inspect to traffic congestion. Okay, so this is called. Okay, next come to flow label. Flow label, this is the flow label. So it is the 4 bit and it may used by the host to label those packets for which it is required requesting special handling by the routers within a network. This is called the flow label. Next come to payload length. It is a 16 bit field. This is the total length of all the extension header plus the transport level IP datagram. Okay. Next coming to next header. It is a 8 bit field. It identifies the type of header immediately followed by the IPv6 header. Okay, and next coming to hop limit. It is the 8 bit field. The hop limit is set to some desired value by source and destination, source and decremented by 1 by each node that forwards the packet if hop limit is decremented to 0. Okay. Next is source address and destination address. So it contains 128 bits, that is 32 into 4. So the address of the originator of the packet, that is 128 bit internet address that identifies the source of datagram. So IPv6 address or 128 bits in the length. Addresses are assigned to the individual interface or nodes. The destination address field is 128 bit internet address that identifies the destination of datagram. Okay, so this is called the source and destination address. Okay, next this is the working of this, and here I having the differentiated services field. It represents the type of services, various combination of reliability, speed, quality of service, congestion parameters are possible. So these are the another field which is available here. This is the different server service, and next coming to extension headers. So IPv6. Okay, extension headers. What is mean by extension headers? IPv6. So we having the IPv6 extension headers, and IPv6 introduces the concept of optional extension headers. So the headers can be supplied to be provided extra information but encoded in the efficient way. 6 kinds of extension headers are defined to present, that is listed below here in the table. Each one is optional, but if more than one is present, they must be appear directly after the fixed header, and preferably in order to listed, that can be listed. And these are the 6 extension headers, that is hop by hop options. So miscellaneous information for routers. Okay, hop by hop option. Destination options, additional information for the destination. So routing, loose list of routers to visit. Fragmentation, management of datagram fragments. Authentication, verification of the sender's identity. Okay, encrypted security payload, information about the encrypted contents. So this is the extension header. Okay, so next coming to internet protocol, internet control protocols. So what is mean by internet control protocols? So I have something available in this internet protocol. So in addition to IP, which is used for the data transfer, the internet has several companion control protocols that are used in the network layer. So they include ICMP, ARP and DHCP. So this has some standard abbreviations that is here. ICMP means the internet control message protocol, and it is nothing but the operation. So it is nothing but IC. So control message protocol, the operations of the internet is monitored closely by the routers when something unexpected occurs during the packet processing to a routers. So what is mean by the operation of the internet is monitored closely. So what are the operations available in the internet that will be monitored closely to the routers? So it sometimes some unexpected unexpected things occurs, something unexpected occurs during the packet processing to at the router. So the event the event is reported to the event. We have some event in that. So any unexpected things will be happen in the processing of data packets during in the router. So the event will be reported to the sender, reported to the sender by ICMP. ICMP internet protocol, it's a internet control message protocol will be sent to the sender. So it is used. So ICMP is used to test the internet. So whenever we get that message, so we will test that message by the internet. About a dozen types of ICMP is also used. ICMP message are defined, and each ICMP message type is carried and encapsulated in the IP packet. So the most important ones are listed here. So this is the table. So this is the message type and this is the description. So whenever the packets we have processing in the packets are processing in at the router. So if any occurrence will be occurred, anything will be occurred on that router. So event will be send the message to the sender. So that messages are destination unreachable. If data is not reached to the destination, that is called destination unreachable. The packets could not be delivered at the destination. This is the description. So time exceed. So within a given time, it is not reached. So time to leave field is 0. Okay. So that is the time exceeded. So parameter problems. So invalid header field. So source quench. So choke packet. Redirect. Teach a router about geography. So echo and echo reply. Check if a machine is alive. So timestamp request or reply. Same as echo but with a timestamp. Router advertisement solicitation. Find a nearby routers. So these are the principles of the message type in ICMP. ICMP means internet control message protocol. So this is the list of the table. Next coming to destination unreachable. What is mean by destination unreachable? The message is used when the router cannot locate the destination, or when a packet with the DF, so bit cannot be delivered because a small packet network stands in the way. So that is called the destination unreachable. Time exceeded message is nothing but is sent when the message is sent when the packet is dropped, because its time to live counter has reached 0. This event is a symptom that packets are looping or that can counter values are being set to low. Okay. So next parameter problems. That messages indicates that an illegal value has been detected in the header field. So this problem indicates a bug in the sending host IP software or possibly in the software of a router transited. So next source quench message was long ago used to turtle host that were sending too many packets. When a host received this message, it was expected to slow down. It is rarely used anywhere because when conjunction occurs. Okay, this is called source quench. Okay, next redirect message is used when a router notices that a packet seems to be routed incorrectly. It is used by the router to tell the sending host to update the better router. So, that is called the redirect message. Next, echo and echo reply. Messages are sent by host to see if a given destination is reachable and correctly alive. Upon receiving the echo messages, the destination is expected to send back an echo reply message. These messages are used in the ping utility that checks if a host is up and on the internet. So, this is called echo and echo reply. Next, timestamps request and timestamp reply. So, messages are similar except that arrival time of the message and the departure time of the reply are recorded in the reply. So, this facility can be used to measure network performance. So, this is called timestamps request and timestamp reply. Router advertisement and router solicitation messages are used to tell host to find nearby routers. A host needs to learn the IP address of the at least one router to be able to send packets of the local network. So, this is called router advertisement and router solicitation. So, next coming to B, ARP, the address resolution protocol. Although every machine on the internet has one or more IP address, these addresses are not sufficient for sending the packets. Okay. So, the ARP association and IP address with the physical address on typical physical networks such as LAN, each link is identified by the physical address. So, the ARP is used to find the physical address to the node when its IP address is known. So, any time of a host, a router needs to find the physical address of another host on its network. It uses the ARP and sends the ARP address resolution protocol query packet that includes the IP address and broadcasts it over the network. So, every host on the network receives and passes the address resolution packet protocol packet, but only the intended recipient recognizes and sends back its physical address, that is link address. So, this is called the address resolution, okay, resolution protocol. Next coming to DHCP, the dynamic host configuration protocol. So, ARP as well as the other internet protocol make the assumptions that hosts are configured with some basic information such as their own their own IP address, how to host get this information. This is possible to manually configure each computer, but this tedious and error prone, that is better way, and it is called DHCP. Okay. So, dynamic host configuration protocol. So, when DHCP, every network must have a DHCP server that is responsible for configuration, that when a computer is started, it has a built-in Ethernet or other link layer address embedded in the NIC, but no IP address. Much like ARP, the computer broadcasts a request for an IP address on its network. It does this by using the DHCP discover packet. This packet must reach the DHCP server. If the server is not directly attached to the network, the router will be configured to receive the DHCP broadcast. DH means dynamic host configuration protocol broadcast, or relay them to the DHCP server whenever it is located. Whenever the server receives the request, it allocates a free IP address and sends it to the host in the DHCP offer packet. So, to be able to do this work, even when hosts do not have IP address, the server identifies the host using its Ethernet address. which is carried by the DHCP discover packet. So, this is called dynamic host configuration protocol. Next, fourth one is OSPF, an interior gateway routing protocol. And internet is made up of the internet is made up of large number of independent networks or autonomous systems that are operated by the different organizations, usually a company, university or ISP. Okay. So, in this inside of the own network, an organizations can use its own algorithm for internal routing or intra-domain routing, also called interior gateway routing protocol. The original Internet Interior Gateway Protocol was a distance vector routing algorithm. It works well in small systems, but less well as autonomous systems grows in size. It also suffered from count to infinity problem. And generally slow convergence. So, it was replaced. It is replaced by link state routing algorithm, and later some modifications are made by to LSR, and that is named as Open Short Path First OSPF. Okay, and become a standard. So, we have some features on OSPF. So, what is that? Calculations of multiple routers to given destination on for each type of services, supports for variety of matrices including physical distance, delay, hop count, etc. It supports the load balancing and distribution of traffic over multiple paths that have equal cost to destination. So, it supports for hierarchical routing. It has authentication schemes to ensure the routers are exchanging the information with the trusted neighbors. So, the provisions for dealing with the routers that were connected to the internet via tunneling. So, OSPF supports both point to point links and broadcast networks. So, this is the features of the OSPF. Procedure. What are the procedures we having? Procedures. When a router boots, it sends the hello message to on all of its point to point lines and multicast them on LANs to the group consisting of all the other routers. From the response, each router learns who its neighbors are. The routers on the same LAN are all neighbors. The OSPF operates by abstracting the collection of actual network routers and links into the directed graph in which each are assigned a weight, distance, delay, etc. Okay, this is the diagram, example diagram. Here I am here using the router R1, R2, R3, R4, R5. So, at every node I am maintaining the LANs, LAN 1, LAN 2, LAN 2 and LAN 4 here. So, here I should be supported LAN 3 here. So, by mistakenly here we are having LAN 1. Okay, this is the LANs we are using. So, LAN is the network here I am using. So, every node I am providing the value, that is node 1. So, this is the node 1 and this is for every node between I am providing the value. Okay. So, that value is a hop count, okay, and this is the hop count, and OSPF works by exchanging the information between the adjacent routers, which is not same as between the neighboring routers. So, during normal operations, each router periodically plots link state UPDA messages to each of the adjacent routers. These messages gives its state and provides the cost used by the topological database. The floating messages are acknowledgements and make them reliable. Each message has a sequence number. So, the router can be see whether an incoming link state date is older or newer than what is its currently has. So, the router also send these messages when link goes up or down or its cost changes. Okay. So, the database description messages gives the sequence numbers to all the link state entities currently held on the sender. By comparing its own value with those of the senders, the receiver can determine who has the most recent values. These messages are used when link is brought up. So, either partner can request the link state information from the other one by using the link state request message. The result of this algorithm is each pair of adjacent routers check and see who has the most recent data and new information is spread throughout the area this way. So, all these messages are sent directly in IP packets, and a few kinds of messages are listed here in the in the table. This is the hello. So, this is the message type hello. This is the description used to discover who the neighbors are. Link state update provides the sender's cost to its neighbors. Link state acknowledgement link state update. Database description announces which data updates the sender has. Link state request information from the partner. So, this is the messages we have get. So, next finally, we can put all the pieces together using the flooding. Each router informs all other routers to construct the graph and its area and compute the short path. Using this information, internal routers can select the best route to the destination outside their area, including the best exits router to the backbone. So, this is called fifth one called OS features of OSPF. Okay. Next, BGP, the exterior gateway routing protocol. So, border gateway protocol is a standard exterior gateway protocol designed to exchange the routing and reachability information among autonomous systems on the internet. So, border gateway protocol makes routing decisions based on path, network policies or rule sets configured by the network administrator, and it is involved in making core routing decisions. Exterior gateway protocols in general and BGP in particular have been designed to allow many kinds of routing policies to be enforced in the inter-asynchronous system traffic. So, typical policies involve political, security or economic considerations. So, in this we are having this diagram. This is the asynchronous system 1, asynchronous system 2, asynchronous system 3, asynchronous system 4. So, this is the control unit. CU is the control unit. Yeah, path of this is the path. This is the path. What is the line here? A dotted line here we are seeing. This is the path. We are moving the packets. Okay. So, the path of BGP routing advertisements dashes. Okay. So, dashes lines is the path of the BGP routing advertisements. Okay. So, path of IP. This line is the path of IP packets solid. Okay. And so, here TR is nothing but transmit, CU is the customer, sorry, C is not control unit, it is a customer, customer is sending, okay, customer, P means peer, okay, P means peer between the node, between these nodes A and B, C, okay. So, this is the customer and this is the transmit, we are transmitting the data packets from asynchronous A1. So, here too it will be moved here, again it will be moved here. So, this is the direction, first direction is solid path of IPs or packets, this is a solid line. So, see this line from A to it moves from the upper side, customer moves the data packets to the asynchronous A1 and again it transmits to the here at the node C and again it moves to the B and again it moves to the A, this slide. Okay. This after we having the after this is the incoming side. So, outgoing side how it will be occur this side direction. So, the A will be send the again send the data to B, I mean acknowledgement and again this like after this like and after this like the direction will be moved. This is the routing policy between the 4 asynchronous systems. Okay. So, this is the diagram of this. Okay. So, up to here we have discussed about the BGP and next, thank you. The next class will continue. So,